Hi everybody, welcome to this training program on transformers. I am Jane Karamchetti, a graduate in electrical engineering from JNTU College of Engineering, Kakinada. I have done my MTech in electrical engineering from IIT Kharagpur. I have a diploma in business and finance from ICFA Hyderabad. I am a certified energy auditor from BEE, Ministry of Power, and a master trainer in solar rooftop grid engineer from NISC of MNRE. I have industrial experience from development engineer to chief executive officer in private companies, multinational companies for 37 years. I have also experience in teaching and training of engineers and executives at Engineering Staff College of India, Hyderabad for 10 years. We have a look at the operations of the transformer, starting with the operations of the transformer involves such processes as external inspection, measuring oil temperature and load, phasing, oil testing, corrective and preventive maintenance. Overalls also included in this. Inspection is performed once in every 6 months. It includes checking of the oil, checking of the leaks, and inspecting the insulators. Each transformer should be equipped with a thermometer measuring the temperature of the insulation liquid. This parameter should also be recorded into the special logbook. If the transformer operated long enough, the temperature of the upper oil layer must not exceed 95 degrees. At the same time, the difference between the temperature of the oil and the ambient temperature should not be more than 60 degrees. If the transformer is equipped with a breather and silica, absorbent color should be noted. Blue color means a good absorption ability. Pink means that the sorbent is nearly exhausted. Load is measured twice a year. First measurement is taken in May or June when the power consumption is minimal. The second measurement is taken in December at the maximum loads, or as it may be differ from your place also. You can change it, no problem on this particular one. Before energizing the transformer, dielectric strength of the transformer oil and its chemical composition must be checked first time when you are doing it. Also, DC resistance of the winding insulation resistance should be checked. Breakers and relay protection is tested. The possibility of a paralleling operation is checked along with the phasing, secondary connection circuits, etc. Parallel operation of the transformers is possible when the following conditions are met. Identical phase displacement, equal turns ratio, equal impedance voltage per kVA, power ratio of something like below 3:1. Preventive maintenance of a transformer is performed at least once in every 4 years, including external inspection and repair of possible problems, cleaning of insulation and the tank, removal of a dirt from the expansion tank and its washing, checking of oil level in the gauge, indicator, and refill the filtered oil if required. Changing of the breather and the silica gel if necessary, checking of a drain valve and seals, checking of earthing and a grounding connection, taking oil samples, measuring the insulation resistance and condition of lightning arrestor. Overhaul of the transformer, overhauling of a transformer, core extraction of the oil change. It is performed if necessary. The decision is made based on the results of the inspection and tests. Many times you will not be able to do it at your site. The most usual issue is the transformer oil leaks, insulation breakdown, short circuit of the windings, mechanical damage to the insulation. In case of a through faults, every transformer should have a logbook with factory specifications, primary operation parameters, and test results. Repair and serving the dates are also recorded in the book. Periodic inspection. 8 recommended periodic inspections of a substation transformer are gauge readings, cooling fans, fluid dielectric test, bushing and surge arrestor insulators, bushing terminals, control wiring, gaskets, and paint finish. Gauge readings. 1 month after the initial energization and annually thereafter, gauge readings of ambient temperature and kVA load should be measured and recorded. Any abnormal reading suggests that the further checking, inspection of or diagnostic testing should be done. If pressure or a vacuum gauge and fluid level gauge readings suggest a possible tank leak, perform the pressure test according to the instructions. This is the prismatic oil level gauge mounted on the conservator. Here you can see two numbers are mounted because the conservator tank diameter is a longer one. This is the Breather-Silica gel. The silica gel color is all pink, in this case, sorry, blue. So it is a very fresh. As you start using it, as absorbs the moisture, the color changes into pink. You have to change it when 80% of the color has been changed. And in the bottom, you can see one plastic cup also is there. You have to fill with a transformer oil into this till the marking is given. That is for filtering the dust coming through the air. And now inspection of oil volume. The volume of the oil has to be verified from the point of view of the insulation from the refrigeration. If the oil level fluctuates notoriously in relationship to the temperature, the cause must be determined for a proper repair. The temperature of the transformer is directly related to the lifespan of the insulating material. Therefore, it is necessary to pay close attention. In case of a transformer built according to the procedures of BIS, the maximum temperature permitted for the oil is about 90 degrees centigrade, and the maximum temperature of the hottest point is 110 degrees Celsius. Now we have a two meters, or you can call a gauges, shown as WTI and OTI, winding temperature indicator, oil temperature indicator. The black needle shows the current temperature at the instant when you are saying. The reading one shows what the maximum already it has touched after you have reset. So the reset you can do once in every week on Monday morning as you come for the duty. So at the end of the week, you know how much is the maximum temperature it has recorded, both oil as well as the winding. Cooling fans. Check the cooling fans if any by setting the fan auto and manual control switch to manual position. The fans should rotate at a full speed within approximately 5 seconds. The fans should rotate smoothly with a minimal noise. Now, oil cooling also, you can see this. This is ONAF, Oil Natural Air Force. You can see the direction arrows are given in this particular one. The arrows shows that that is the direction of the oil in which it is going. The hot oil is going from bottom to top and coming into the radiator, and in the radiator the oil is getting cooled down. So oil is going from top to bottom and the circulation continues in this particular one. There is a fan also provided here for a better cooling in this. In this, you don't find any pump or the motor for the oil flow. Fluid dielectric test. Sample the insulating fluid as described below. The dielectric strength of the insulating fluid should measure at least 26 kV. Sampling of insulating fluid can be done. Transformers are filled with insulating fluid which provides electrical insulation within the transformer tank and transfers the heat generated in the coils to the tank wall and the radiators. Fluid dielectric test. The fluid is either conventional transformer oil, what we call it as a mineral oil, or environmental temp for3 fluid, or silicone fluid, or any other fluid also, which new ones are coming. It is also recommended that a fluid sample be drawn annually and tested for the dielectric strength of their oil. Samples should be drawn from the bottom of the tank. Use proper sampling procedure to prevent the erroneous test result. Dielectric strength should measure minimum 26, but maximum can be about 50 kV per 11 kV application. While taking the sample, if a half a liter is required, take a bottle of half a liter only. First, put a small amount of oil and rinse the bottle inside and throw away that oil, and then collect the sample oil up to the neck full without leaving any air on the top of the bottle. Bushing and surge arrestor insulators. Bushing and surge arrest insulators should be clean. If the surfaces are excessively dirty, they should be cleaned while the transformer is not energized. Bushing terminals. If the transformer is energized under load, measure bushing terminal temperature using an infrared scanner. Excessive bushing terminal temperature indicates a loose or a dirty connection. If the transformer is not energized, use a torque measuring device to make sure terminal connections are tight. Control wiring. Control wiring should be checked to ensure that wire insulation is in a good condition. The control cabinet and associated conduit should be inspected to ensure that weather seals are intact. Control power supply voltage should be checked and compared to the voltage stated on the wiring diagrams. Oil leaks. Oil leaks can be caused by the deterioration of some gaskets or they are in a wrong position. It takes some time to discover them. Check carefully the valves and the gaskets. If there are any defects that could be cause a leakage, report it to your team leader and attend on to the job. Gaskets. Virtually check all the gaskets of a crack or other signs of deterioration. Replace as necessary. When replacing a gasket, carefully clean mating surface to remove any dust, dirt, transformer fluid, old gasket material, or other contamination that might prevent a good seal. Use an appropriate gasket cement when installing a new gasket. Once you have opened the top cover, the old gasket cannot be used. You have to put a gasket. So before opening the top cover, please may ensure that new gasket is available with you. Holes are punched on that. Inspect the paint finish for a damage or a weathering that exposes the primer coat given on the bare metal. Repair any paint damage that might be found. Periodicity of inspection. The table shows that number one, if we take a thermometers once in every year and accessories with alarm contacts and once in every year and verify the operation conditions of the contacts and measure the insulation resistance of the circuit. Cooling fans once per year if any anomaly is found. Otherwise, a conservator also once in every 5 years you can clean it. Insulation resistance of the winding once per year, and when a sharp change after years of use noticed, then a change in comparison with the data registered with the previous tests. Measurement of a tan delta once in 3 years, just as in the 0.5. Oil breakdown value once in every year. Value of acidity of the oil once per year. Test of the functioning of the oil. Check if there is any abnormality noted in the tests of the items to the 5th to 8th. Filtered insulating oil. Check if there is any abnormality noted in the tests items of 5 to 8. Inside the components, once in every 7 years, we should do that. Thank you very much to you for the patient listening.